Hey everyone, in this tutorial we'll be discussing the VI characteristics of SCR. So it's a graph of anode current IA on the y-axis and anode to cathode voltage plotted on the x-axis. It can be divided into two parts. First, forward characteristics, second, reverse characteristics. So here V stands for voltage and I stands for current. VI characteristics is nothing but the voltage and current characteristics of SCR. It's a graph of voltage versus current. So here you can see on the x-axis we are going to plot the voltage will be shown here on the x-axis, whereas the current I will be shown on the y-axis. So here, as you can see in the graph, the forward characteristics will be discussed here. It's shown in the first quadrant of the graph, whereas the reverse characteristics is shown in the third quadrant of the graph. Here is positive anode voltage, here is negative anode voltage, here is positive anode current, and here is negative anode current. So here VBO stands for forward breakover voltage, VBR stands for reverse breakdown voltage, and IG is the gate current, IA is anode current, VA is anode voltage, K means cathode, and IBO is breakover current. So the forward characteristics can be seen in the first quadrant of this graph, whereas the reverse characteristics can be seen in the third quadrant of the graph. Now talking about the forward characteristics, our SCR is forward biased. That means anode is positive with respect to cathode. The forward characteristics can be basically divided into three modes of operation, and they are forward blocking state, transition state, and on state. Now this one, the first state, that is forward blocking state or forward blocking mode. Here our SCR is in off state. The second state is the transition state. Here the SCR is off. Here this is the transition state where our SCR is neither completely off nor completely on, but it is switching from off state to on state. Transition means switching. The third state is the on state. It is also called as the low voltage high current mode, and it is called as the on state where our SCR is completely on. Now talking about the reverse characteristics, here you can see here in the third quadrant. For reverse characteristics, our SCR is reverse biased. That means anode is negative with respect to cathode. Here what happens is when our reverse voltage is less than reverse breakdown voltage, very small leakage current flows here. Very small amount of leakage current will be flowing until and unless the reverse voltage reaches breakdown voltage. That means reverse voltage becomes equal to breakdown voltage. Here when our reverse voltage reaches a certain point, that is breakdown voltage, suddenly what happens? Avalanche effect takes place. So here avalanche breakdown takes place and a huge amount of current starts flowing in the SCR. Earlier what was happening was only this much amount of current was flowing here. Only this. A very small leakage current flows until and unless our reverse voltage reaches this point. This point is called as reverse breakdown voltage. And when a reverse voltage reaches this point, suddenly avalanche effect takes place and a huge amount of current starts flowing through our SCR. So this is nothing but the reverse characteristics of SCR, which we'll be discussing further in detail. Now we'll be discussing the forward characteristics in detail. So the SCR is forward biased. The forward characteristics is divided into three regions of operation. So as I said earlier, the SCR is forward biased. That means anode is positive with respect to cathode. And our forward characteristics is divided into three regions of operation that we'll be discussing one by one. So the first one is forward blocking state. In this state, SCR is in off state. This is the high voltage low current mode of operation. Current through it is called as forward leakage current. Current flows due to minority carriers. So as discussed earlier, in the forward blocking mode, our SCR is off. It's in the off state, and this is the high voltage. Here the voltage is high whereas current is low. The current that's flowing in this state is called as forward leakage current. And the current that flows is due to minority carriers. So the second state is the transition state. SCR remains in blocking mode until forward anode to cathode voltage is less than the breakover voltage. As soon as VAK is greater than VBO, the anode current IA increases sharply to a high value and voltage reduces sharply to a low value. The switching of SCR from off state to on state is called transition state. So here in the second state, our SCR remains in the blocking mode. Blocking mode is the first state. Our SCR will remain in the forward blocking mode unless and until this condition is satisfied. That is VAK, forward anode to cathode voltage is less than breakover voltage. Until and unless our VAK is less than VBO, the SCR will remain in the first state, that is forward blocking mode. But as soon as this condition becomes false, it changes, that is VAK becomes greater than VBO. Here VAK, if it becomes greater than VBO, the changes will be seen. The changes that will be seen is the anode current increases sharply. Current will suddenly increase and voltage will suddenly decrease. Here I should have had added the graph for better explanation, but I'm sorry I didn't do that. You have to go back to the first slide to see the graph. But nevertheless, I gave you a short explanation in the beginning. So this is just a detailed explanation of the previous one. So our transition state, this is nothing but the switching of SCR from off state to on state. That means our SCR is neither completely off nor is it completely on, but it is in between. It's transiting from off state to on state. So the third state is forward conduction mode. SCR is in on state. This is the low voltage high current mode of operation. In this mode, voltage is low and current is high. Voltage drop is small. So this is the third region of operation of forward characteristics of SCR. In this state, in this mode, our SCR is turned on. It's completely on. And here the voltage is low whereas the current is high. This state is also called as low voltage high current mode of operation, and here the voltage drop is small. Here we'll be discussing the reverse characteristics. SCR is reverse biased. It's non-conducting and operates in reverse blocking mode. When the reverse voltage is less than reverse breakdown voltage, a very small leakage current flows. As soon as the reverse voltage reaches breakdown value, the avalanche breakdown takes place. A large reverse current flows, whereas the voltage remains constant. The operation in the breakdown region should be avoided as it can damage the SCR permanently due to overheating. So for reverse characteristics, our SCR is reverse biased, that is anode is negative with respect to cathode. It is in non-conducting mode and operates in reverse blocking mode. Unlike forward characteristics, our reverse characteristic has only one mode, and that is reverse blocking mode. So when the reverse voltage, that is the negative side, minus VAK is a negative anode voltage, anode to cathode voltage. So when our reverse anode to cathode voltage is less than reverse breakdown voltage, that is minus VAK is less than VBR, a very small leakage current flows. If you look in the graph, there it's shown clearly that only a small current is flowing when VAK, negative VAK is less than VBR. But as soon as the reverse voltage reaches breakdown voltage, as soon as minus VAK becomes equal to VBR, when the values become equal or when VAK reaches a certain point, that point is called as breakdown value. When it reaches this point, the avalanche breakdown takes place. So what happens in avalanche breakdown is a large reverse current flows. If you see the graph, there will be a sharp turn in the graph, and at that time a huge amount of current starts to flow all of a sudden, whereas the voltage it remains constant. The current it keeps on increasing, whereas the voltage remains constant. So this is nothing but the reverse blocking mode of SCR, and this reverse blocking mode should be avoided. Now why it should be avoided is because it can damage the SCR permanently due to heating. So here are some important terms that you need to know while studying VI characteristics. The first one is VBO, that is forward breakover voltage. This is the maximum forward voltage that can be applied between anode and cathode without initiating forward conduction. This voltage is defined for a zero gate current. In short, this is the maximum forward voltage across SCR in its off state. So VBO, that is forward breakover voltage, it is the point at which our forward anode current, when it reaches this point, it changes its state from blocking mode to conduction mode. Now the second point is VBR, that is breakdown voltage, the maximum reverse voltage at which the SCR starts conducting heavily is known as the reverse breakover voltage. So this term VBR, that is breakdown voltage, it is defined for reverse characteristics of SCR. So this is the point, VBR is the point at which when our negative, that is reverse voltage, reaches the point VBR, at that time avalanche effect takes place. And what happens is a large amount of reverse current starts flowing. So it's nothing but the maximum reverse voltage at which our SCR starts conducting heavily. Now the third term is IH, that is holding current. It is minimum current that can flow through SCR and still hold it in the on state. So holding current is the minimum current that is required to hold the SCR in the on state. So you know when SCR changes its state from blocking mode to conduction mode, a huge amount of current starts flowing in it. So the minimum current which is required to start the SCR to keep it in the on state is called as holding current. Whereas latching current is the minimum current required to latch SCR in the on state. So to this one means to bring it in the stable state. When the SCR is in a stable state, it is completely turned on. That current is called as latching current, and the current which is required to bring it in the on state is called as holding current. We'll see the difference between these two in the next slide. So here comes the difference between holding current and latching current. Holding current is associated with the turn off process of SCR. Latching current is associated with turn on process of SCR. Now why this is associated with the turn off process? If you look into the graph, you'll get a better idea. So in the graph, IH that is holding current is located between the blocking mode and conduction mode of SCR. It is in between those two processes. Whereas the latching current, it is there when our SCR is completely turned on and it comes to a stable state. Second point, thyristor can be turned off or returned to forward blocking state only if forward current falls below a low level current called the holding current. It is the minimum value of anode current which it must attain during turn on process to maintain conduction when gate pulse is removed. So if the current flowing through the SCR is below holding current, our thyristor or SCR or our device can be returned back to the blocking mode. Whereas latching current is the minimum value of anode current which it must attain. That means it has to reach that minimum value of current it should have to keep itself in the on state. That means even if the gate pulse is removed, it will still be in the on state. It is that minimum value of current which it must attain. So latching current is the minimum value of current it must attain during the turn on process. During turn on process to maintain conduction, even if the gate pulse is removed. Okay, moving on to the third point. Holding current is less than the latching current, and latching current is 2 to 3 times of holding current. So it's clearly seen here that holding current is less than the latching current. If you look into the graph, you will get a better idea. Holding current is always less than latching current, and latching current will be greater than holding current up to 2 to 3 times. If you have found my videos helpful, then do hit the like button and subscribe for more. Thank you.